This is chapter 4, 81. This is the ski jumper problem. Okay, so you're going to have this ramp, and it's going to go off at some angle. We'll call that phi. Okay, and then the ramp you're landing on is also sloped with some different angle. Okay, so there's the ramp. So the skier goes off and lands on the jump. Okay, this angle is theta. Let's call this x, and let's call this y. It's going to be important that we end up relating theta, x, and y together. Okay, so if you think of our standard equations, how far he goes is v naught cosine. You got to think about it for a second. Theta or phi? Well, phi is the angle you're actually launching with. Okay, that represents the horizontal velocity, and then times that time. And then your vertical is y naught plus v naught sine phi t minus 1/2 gt squared. Again, that's very typical. Again, this angle is related to your horizontal and your vertical velocities. Okay, so let's solve for time. The time we use, well, we're going to hit this at a certain amount of time. We've traveled a certain amount of distance. So then we can say then the time is x over v naught cosine of phi. Okay, and then there's another relationship we can say. So we can take this time, we can plug it into this equation. So the question is, it doesn't really matter. You can treat this as 0 and then your original height as y, or you can treat the original height as 0 and then this is negative y. I'm going to say that again. This can be y and this can be 0, or you could have made this 0 and this negative y. It's not going to matter. So for us, let's make our coordinate axis right here. This is y versus x, and so this has a y value of 0. The ending y value is 0. So that 0 equals this y value height, right, the original height, plus v naught sine phi times t, which is x over v naught cosine theta, cosine phi, minus 1/2 g, and then t squared is that x over v naught cosine phi squared. Again, very similar to questions we've done in the past. It's very similar to the lab question. But you look at this one, it's like, wait a second, I have too many variables. But you don't, because you can relate y and x. Okay? So really what you want to be able to do here is this y value, come down here and say, well, tangent of theta, again, this is where theta comes in, is y over x. So that must mean that y equals x tan theta. So now you can plug that in here, and at this point you have everything. Okay? The only thing you don't know is the distance. Okay, because you know the ramp angle. So phi is 50 degrees. Nope, excuse me. Phi is 15, and the angle you land with is 50 degrees. Okay, so we plug all of that in. So really what I'm saying here is that 0 equals, instead of y, write x tan theta, plus these v naughts cancels and we get that typical x tangent of phi, minus, and again it's the same kind of thing, g x squared over 2 v naught squared cosine phi squared. Okay, this is the theta and those are phi's. Now I have everything except for x. And I can find x. X is equal to 27.8. Once I know x and I know theta, I can find y. Y ends up being 33.13. But once you know x and y, you can figure out how far down the ramp you actually land using the Pythagorean theorem. And so the ramp distance ends up being 43.2 meters. Of course, these are in meters. Okay, the time it takes, well, you know your original horizontal velocity. So Vx was just V naught cosine phi, and so that's 9.66 meters per second horizontally. So if you're going 9.66 meters per second and you want to go 27.8 meters, you're pretty much just going to have to go about 3 seconds. So again, you're really plugging back in here to find time. So then the total time is 2.88 seconds.